Hello, everybody, and welcome to AWS Summit Berlin 2018. Thank you so much for coming, and thank you for logging into Twitch. Big shout out to our Twitch audience here. First time I'm running a talk on Twitch, so very excited here. But also thank you for coming in here in person. We have thousands of people coming to Berlin to the AWS Summit, and I'm very glad to see you here for this session around building your first machine learning application on Amazon SageMaker. My name is Constantin Gonzalez. I'm a Principal Solutions Architect with Amazon Web Services in Munich. And I've been super excited when Amazon SageMaker got launched, because that was exactly what I wanted as a developer in order to really dive deep into machine learning. And I hope to give you some of that enthusiasm as we walk through our next couple of slides and, of course, a live demo. So this is what you're hopefully going to get out of this session. We're going to walk through an overview of the machine learning process so that you get a feel around how does it go from data to machine learning in production. I'm going to give a quick overview of Amazon SageMaker, but most of this session is going to be a live demo on SageMaker in action so that you get a feel about how it works as a tool for you. We're going to see some examples of using Jupyter notebooks, of using Jupyter for extracting features and preparing data for your application. We're going to have a very quick rundown through the available algorithms in Amazon SageMaker. And we're going to see how you can build and train your own SageMaker models in this service. And of course, at the end, there's going to be plenty of opportunities for you to do question and answer. So let's start with a quick overview here. So who is a developer here? That's good. So you came to the right place. So who is a data scientist? OK. Who is a non-technical person? OK. There's going to be something for you as well. But as a quick overview, Amazon has been having a very long history of using machine learning from the very first instance of the Amazon homepage that already offered product recommendations more than 20 years ago to new services like Amazon Go, where we have an entirely new shopping experience in a brick-and-mortar store powered by ML. We have been employing machine learning all over the place. And our goal at AWS really here is to help you take advantage of the expertise that we have built up over the time so that you can start developing your own algorithms or running your own applications based on machine learning as quickly as possible, and then hopefully contribute to the large pool of machine learning applications that all of our customers are building right now on AWS. As a quick overview, AWS offers a lot of infrastructure and frameworks. So, of course, we do virtual machines. And there are some different virtual machine instance types to choose from. The P3 instance type comes with the latest NVIDIA GPUs. As you may know, machine learning runs really, really well on GPUs, especially if you're using it for deep learning. So we can give you the latest NVIDIA GPUs to run your machine learning algorithm on top of. And we also support all of the different learning frameworks as part of the AWS Deep Learning AMI. So if you just want to set up a machine and run a machine learning algorithm, run a deep learning algorithm on any of the popular frameworks, it's as easy as selecting the Amazon Deep Learning AMI, running it on EC2, and then you can get started there. And one important thing here to note is that at Amazon, we're not going to tell you this is the one tool to use and go away if you're interested in another tool. Just like the Amazon store, where you can choose between country, Western, and gazillions of other music genres, of course, we support you with whatever framework you prefer. Right now, frameworks like TensorFlow, MXNet, PyTorch, and CNTK, and the others you see here are among the most popular. But if you're missing your favorite framework here, feel free to come to us and tell us about your favorite framework where we can find it, and then we'll figure out a way to support you using even the most exotic or the most new framework on AWS. Later on, we also offer some platform services that kind of abstract away some of the complexity of running machine learning in production. And this is what SageMaker is all about. So Amazon SageMaker is a complete end-to-end machine learning platform that offers everything from the developer workbench to the training process to the deployment process at scale. And it also supports all of the popular frameworks here. And you only pay by the second, which is very important, because machine learning can involve a lot of hardware, it can involve a lot of GPUs, and if you were to buy and operate and run them on premises, it could quickly become very expensive. With Amazon SageMaker and the automation that goes along with it, you get access to the latest hardware technology for machine learning, but you only pay for the seconds that you really use that technology for your application. And finally, there are also some application services. So if you know nothing about machine learning, and if you're not interested in developing anything that is close to a machine learning algorithm, you can still use the application services, which include services for vision, for speech, and for language, by simply putting in an image into the Amazon recognition service and getting labels back powered by machine learning technology. So even if you can only write some simple lines of code, you can take advantage of our machine learning expertise here. So with that, there's lots of tools that you can use, but let's dive deeper into the actual machine learning experience in which you are training your own model. So if you're training your own machine learning model, a lot of things need to happen. And it always starts with a business problem. And tomorrow there's a whole talk around how to find the right business problem and how to map it to a machine learning problem. But to be honest, machine learning is cool, but at the end of the day, you need to make something useful out of that. And that is where you talk to your business people and try to identify use cases where a machine learning algorithm may add value to your business. So the next thing you need to do is you need to frame that business problem as a machine learning problem. It means like, how can I identify interesting objects in an image that I'm interested in as a business? Or how can I identify a sentiment value out of a Twitter post or something like that? Or how can I detect a part in my industry 2.0 machinery or 4.0 machinery that is about to break? And how can I map this to the data I'm collecting from that IoT system? So once you frame that problem, the next step is where the work really starts. And it starts always with data collection. Machine learning is all about crunching a lot of data and identifying patterns in the data that the machine learning algorithm is going to recognize. So it always starts with collecting data. If you don't have data, you can't train a machine learning on top of it. So it's really important to have a good data strategy and have a good mechanism for collecting data from different bits and pieces of your company, from your IoT devices, from your mobile apps, or wherever your data is coming from. And this is why data lakes are becoming so popular with our AWS customers. Once you collect the data, you probably want to integrate data from different sources, and you probably want to prepare the data, clean the data, identify missing bits and pieces and fill them up with some sensible value, and generally pre-digest the data so that it becomes easier to use in a machine learning context. After collecting, integrating, and preparing the data, this is where you first start looking at the data, trying to identify opportunities for machine learning. So that involves some visualization. There are lots of tools out there. You can use a business intelligence tool, you can use Amazon QuickSight, or you can use a developer environment such as a Jupyter Notebook to visualize the data and get a feel for it. And the next step after visualizing the data, once you get a feel about what are the parameters that are interesting to build my machine learning on top of, is feature engineering. This is where you extract specific attributes from the data that you want to feed into a machine learning algorithm. And after that comes the actual model training part, where you train a machine learning model with a training algorithm. And then after training the model, you probably want to know, is this model going to work? Or is it just going to give me some response that is completely random? So you probably want to do some testing, some evaluation of your model that is based on some training data which is separate from test data which is separate from training data, and get a feel about how well the model performs. And that might involve some tuning as well. So maybe you're using the wrong parameters, and if you use better parameters, you get a better model. So there is a lot of science behind tuning your models, and this is what we call hyperparameter tuning. So after evaluation and tuning and training, maybe you haven't met your goal yet. Maybe it wasn't the right algorithm, or maybe you're still missing data that has the power to predict something, and you go back to square one, where you collect more data or better data in order to feed your model. And maybe it's not just about collecting more data. Maybe you haven't extracted the right features. So you want to play with the data and try to identify, what if I add the mean and the sigma or the standard deviation to my data? Will that probably help my machine learning algorithm identify patterns better? Or what if I can filter the image using those filters to make it more digestible for my next pieces in the pipeline? So think about how you can augment the data through collecting more and better data, or how you can augment the data at the visualization and feature engineering part, where you can try to extract better features before you feed them into your machine learning algorithm. And assuming that the model is successful, it provides you with a good prediction, then the work of putting it into production starts. It's a wholly different environment. A training environment typically involves a lot of scale, and that's fine. A production environment may not involve as much scale, but it has different requirements. It needs to be very highly available. It needs to scale based on the demand that you're seeing in production. And you probably also want to see some monitoring and debugging here, because by collecting monitoring data from real-life use cases, you can actually add to the data collection phase. By collecting real ground truth data from the real world, from user feedback, you can then augment the data collection phase, and then the whole cycle starts from scratch. So the point here is, this is the whole process on a technical stage. And the key idea here is that SageMaker is designed to help you through all of the stages of this process. So it's one tool set that you can use to attack all of these individual stages and run in circles. And you can either do it interactively, like we're going to do in a couple of minutes, or you can embed it into your overall continuous deployment process in a fully automatic way. So think of the whole cycle here running completely automatic every week based on new data that you collect across the week, and getting a better model every week that improves over time as you add new data to it, completely automatic and part of your continuous deployment pipeline, including running it in production. That is the goal here. Try to embed your whole machine learning process into your complete continuous deployment pipeline and make it part of your automatic setup here. So with that, let's take a look at the real thing here. So the first thing you probably want to do is creating a notebook instance. So who is familiar with Jupyter Notebooks in this audience? So that's about a quarter or so. Okay, so please forgive me if I explain some of the basics for those that haven't raised their hands yet. So a Jupyter Notebook is a web-based environment that, as a developer or as a data scientist, you can use kind of like a workbench or a graphical user interface to playing with data in a language that you like. I happen to like Python, and it seems to be a very popular language, but if you want to use R or any other language, that's perfectly viable as well. So Jupyter Notebooks are currently the most popular software for running a notebook environment, and we are going to run our examples in a Jupyter Notebook. And if you're wondering, how can I run a Jupyter Notebook? Do I need to install something? That is exactly what this step here employs. So if you log into the Amazon SageMaker console, the first step is creating a notebook. You specify a name, the instance type, a role that you want to associate that gives you the permission to use other AWS services, and then it creates your Jupyter Notebook in your favorite VPC or in a VPC that is publicly accessible. So it takes all the complexity away of running a notebook environment and makes it as easy to use as an RDS database. So let's do that and then work from there. So as I said, this is the AWS console. Let's make the font a little bit bigger so you can read better. And here's the SageMaker interface. We switched networks, so there's a small networking thing here. There's a dashboard. Here's a big friendly Create Notebook Instance button. I already did that, so let's move on to our actual Jupyter Notebook. This is how a Jupyter Notebook environment looks like. It looks like a file browser because it is in the beginning. You see the files on your home directory, and I have created a couple of demo notebooks that you can use to familiarize yourself with Amazon SageMaker. Actually, the nice thing about SageMaker is it comes with the whole library of demonstration notebooks that are ready to use, ready to try out. So if you're interested in a particular algorithm, such as, how to run a deep neural network in TensorFlow on SageMaker, you simply pick the right notebook from the GitHub repository here, from the examples, and to make it even more convenient, they are already pre-installed in the notebook environment. So when you open up your notebook environment, you already see this directory here called sample notebooks, and this is where all of the samples live and where you can browse them and try them out and see how they work. So as a first example, I picked a very simple machine learning algorithm, which is a linear learner. So who is familiar with linear regression in this audience? Okay, that's about. So if I don't know anything about something, what do? You go to Wikipedia, right? So let's go to Wikipedia and look up linear regression real quick, just to remind ourselves what this is about. So linear regression is a very, very simple algorithm Some people don't even count it as machine learning because it's so simple, but let's start with it. So linear regression is an algorithm that takes all of your data points. So the data points here are the blue dots here. Let's make the image bigger. So in linear regression, this is the data that you use for training, the blue dots here. And in this case, we have 2 dimensions, 2 values, x and y, that the data takes with it, 2 attributes. And we want to predict what is the data that is going to come out if I put in a value of 50, what is going to be likely the result on the y-axis. And in order to do that, a linear regression algorithm tries to plot a line across all of the, that is as close as possible to all of the known data points in order to estimate a result here. So if we look at the line, if we plug in 50, the expected value would be around 12.5. That is the result of our algorithm. Super simple. Everybody did it at school somehow. Now imagine doing that with 300 variables. So if you do that with 300 variables, you end up in a 300-dimensional vector space, which is a bit more complicated than plotting a single line. And this is why we have a built-in algorithm in Amazon SageMaker to do that for us. So this is the example notebook for using the linear learner. And as an example data set, we're using the MNIST data set. The MNIST data set is a collection of handwritten digits. So they literally took lots of bookkeepers and their books, and then they extracted all of the handwritten digits from those bookkeepers' books, made them into some pictures. And now we want to predict whether the bookkeeper wrote a 0 or a non-zero digit into the book by feeding all of the pixels into a linear regression algorithm. That is what this example is about. And now you see how a Jupyter Notebook works. You see cells here that look a lot like HTML because they are. And you can write down your notes in such a cell, either in HTML or in Markdown, just to keep a note of what you're doing. So a Jupyter Notebook really is a notebook in the sense of you can write stuff down, but it also includes code. So in this case, we have a code cell where you can write down code in one of the supported languages. In this case, it's Python. And if you execute that cell, that code gets executed. So it's a nice way to mix and match your documentation, your notes, with actual code that you are running here. So what we're going to do here is we're going to work through this notebook and thereby execute this example that uses SageMaker to train a linear learner model. Some introduction here. I'm going to skip about that. The first step here with SageMaker is simply telling your programming environment where your data lives. So in this case, I created a bucket here that you see here. So this bucket over here is my Amazon S3 bucket where I'm going to upload my training data to so that SageMaker can access it. And if I want to tidy up my state, here's a prefix, something like a subdirectory, so I know where the data is. Very simple stuff. And the rest here is simply importing the Boto library, which is the AWS SDK, a regular expression library. And we're also importing a SageMaker-specific library that will give us our execution role, because we want to hand over SageMaker the role that we are using to run all of this stuff and give it permission to use AWS services on behalf. So simple stuff here. As you can see, when you execute a node here, there's a small star appearing, and after executing the code, you see a number, which is the number in the sequence of stuff you executed. Very easy stuff. So Jupyter Notebooks is just a command line environment that is mixed in with documentation. Now the interesting stuff happens. The first interesting part happens here. This is where we ingest data. In this case, we're downloading training data from an external web page. So this is just Python code that downloads our training data, and then it opens the GNU-zip file where the data is packaged up and unpacks the data. This takes a little bit longer. It's a couple of seconds until everything is downloaded. And then we can take a look at the data. So with this code here, we're actually visualizing one example digit. So this is a 3-ish sort of character that is part of the MNIST data set, just to get a feel of the data. Now, how are we going to give this data to our machine learning model? In this case, we need a numeric representation of the data. So each image here is a 27 by 27. Let me just check real quick. Yeah, I think it's 27 by 27 grid of pixels. So each pixel has a grayscale value between 0 and 256. So what we're going to do is we're going to pump all of the 27 by 27 grayscale values into our linear learner, pretend that they are points and dots in a 27 by 27, that's 700 something dimensional space, and let it all figure out by plotting lines through the data and trying to identify zeros from real digits. That's what we do here. And if you look up the documentation, then we learn that the linear regression algorithm expects data in a format called protocol buffers or protobuffer. So what we need to do here is we need to convert all our images into protobuffer data, and this is what this cell here is doing. So this is a bit code that takes the data that we loaded, and then it uploads the data to Amazon S3 on it takes the data we loaded and it creates a protobuffer, a record I/O wrapped protobuffer data structure that can be digested by the machine learning algorithm. And the next step actually is uploading the data into Amazon S3. So that's the data preparation bit. In your case, you may want to write some Python or some R or some other classes that pre-digest the data in a different way. So maybe you want to crunch the data by computing mean and standard deviation numbers, or you want to filter out invalid values from the data, or you want to mix it up or something else. This is where you would do the pre-processing in an interactive way, or if you want to put it into production, this is something you can run as a batch job that batch imports the data, batch processes the data, and then dumps the training data into Amazon S3 as a training data set. So the next step that we need to do here is, once we have the data on S3, is to train the actual model. Now, the nice thing about SageMaker is that it supports everything you can put in a Docker container. Because, if you will, SageMaker is an orchestrated execution environment for Docker containers that happens to be optimized for machine learning. So every machine learning algorithm that SageMaker supports is living in a Docker container. And in this case, the code simply tells us if you are in the region US West 2, this is the ID of the Docker container that contains the machine learning linear learner model. So if you want to use one of Amazon's own models, you simply look up the right container here from our documentation. If you want to create your own deep learning model based on TensorFlow, MXNet, or any other framework, you simply use one of the pre-built containers that have all the hooks in place to put in your TensorFlow or MXNet script, and then you use that prefabricated container to load the data and load your own deep learning network. Or if you have your own exotic, super specific, very cool machine learning algorithm that is really cool, you can wrap it into a Docker container and hand it over to SageMaker so that it can take care of running it at scale and using it as the basis for your own machine learning application. So it's all containerized. So let's do that. Let's figure out which is the right container. And in this code here, we start the actual training process. Since training in this case takes about 5 minutes, and I don't want to sit around and bore you for 5 minutes, I already run the training for you. So this is what you get. Here's a simple API call that creates the estimator object, where all of the parameters are, which container, what role, how many instances I want to train on. Nice thing about machine learning is that most of the time it's nicely parallelizable. So if you have a lot of data, you can train in parallel on 1, 10, 100 instances, and you simply change the number at this stage here to tell SageMaker how many instances you want to train on. You can pick a specific instance type here, again, depending on how your algorithm performs. If it needs a lot of memory, you pick an instance with more memory. If it needs a GPU, you pick a GPU-enabled instance. You can choose the right instance type here. And here's where we give it the output location where the model that has been trained is going to be output to. So for instance, if you want to train a machine learning model that is going to be deployed on a device, on an IoT device, you can pick it up, you can train it in the cloud with SageMaker, take it from the S3 bucket where the model pops out and put it into your IoT device. Or you can get the next step and deploy it into production. So the next thing is, this is where we specify the hyperparameters. These are the 784 values that we get out of our 27 by 27 pixels. This is where we tell it, okay, we want the binary classification algorithm, and here's the mini batch size. So it's not going to feed all of the 10,000 images at once. It's not going to feed them one by one. It's going to feed them in batches of 200 into the training algorithm. So this is where you can pick here the batch size, and that's a tunable parameter. It kind of is a trade-off between being slow because you feed it just one by one, or being super fast by feeding everything at once but getting a lower precision outcome. With 200 in the middle somewhere, we get a really good mix of both. And then you see all of the log output of that actual training process. So this is where the training really happens. These are the batches that are trained one after the other. Every batch contains metrics. So what you can do here is you can look at the logs as a human, which is not really attractive, or you can pipe those logs into your own monitoring environment and get a monitoring view on your logs, and you can process those logs to determine automatically whether this week's model is really better than last week's model, and maybe you want to discard the new model for the old one because the old one really was better. So you get full control over the log output here, and in this case, we are simply displaying the log just to illustrate the point. And the final log output here is a summary of the outcome, which includes quality metrics like precision, recall, or F1 score. So if we look at the output metrics, we learn that our F1 score here, which is a mixture of different metrics, it's about 96% F1 score. It means that roughly this model, after training, was able to recognize 96% of those digits either as being 0 or non-zero. So seems to work pretty nice, even though it's a very primitive algorithm. So after training, the next step is to set up our hosting environment for the model. And it works very similar to the training code. So instead of getting an estimator code, we create a deployment object here using the SageMaker library. And that deployment has similar parameters like instance count and instance type. Typically for deployment, you would use a smaller instance type because deployment uses less CPU and RAM as the training stage, but it may depend on your algorithm. And that will create the model with this endpoint configuration. And after creating this endpoint configuration, we are ready to actually run some tests here. So what we do here is we run through some code that helps us serialize and deserialize our model and put it into production, and then we can start running some predictions. So this code here, so in the beginning, again, this code here takes about a couple of minutes to set up the hosting environment, and the thing that happens behind the scenes is SageMaker will create a fleet of machines, either one or many machines. You can either tell it to auto-scale the machines based on demand. So you can start with a single machine, and as more and more users use your endpoint, maybe you're using this model as part of a mobile application that uploads a lot of data and you have millions of users and growing really quick, then it will automatically add more instances to your hosting fleet that will take all of the load. And the other thing about hosting, to be honest, a data scientist is not the most competent person to run a RESTful web services at scale, including security, including caching and authorization and all of the other things you need to go through in order to publish a robust web API. At least I don't know that many data scientists. And even if you do know how to do this all of your own, you probably want to spend more time doing data science and less time doing infrastructure. And this is where SageMaker really helps you, because it sets up the whole RESTful web services endpoint for you that is nicely easy to use, just like any other AWS API, and sets up the whole fleet automatically for you, so you don't have to worry about anything. And the way to use this endpoint is very simple. You simply create this predictor object here, tell it what where the endpoint is, and then you run the predict method with the input data, and you will get an output as a result. So in this case, we are looking at one of the images, image number 0 here, and then the result is that we get a score of 8.56 with a predicted label of 0. 0 meaning this is not a 0. Sorry for the confusion here, but it tells us the outcome of the model. So this is how easy this looks from your own web application. So you can embed this call into your web application, into your mobile application, to wrap around the whole RESTful API that has been created for you running your model. Okay, so linear regression, it's kind of boring. Let's look at an example that is a little bit more colorful, in this case, image classification. And maybe this is a good way of introducing you to the algorithms that SageMaker supports. So if you go to the documentation, how do you find the documentation? Well, it's very easy. You simply type in aws.amazon.com/documentation. I swear I run into customers all the time who didn't know that, so I'm just want to point this out. aws.amazon.com/documentation. You see documentation for all of the services here, and you simply find SageMaker here somewhere, right? Since we have 125 or more services, I really need to use the find mechanism on my web browser here. So here's the SageMaker documentation. This is one of the best documentations I have seen because it comes with all of the algorithms nicely documented. It comes with examples, and it's really worth to check it out. Part of the documentation is the chapter around using built-in algorithms, where you get a list of all of the built-in, ready-to-use, fully optimized SageMaker algorithms. So we have been using the linear learner algorithm before. Now let's take a look at the image classification algorithm. The image classification algorithm is a pre-built deep convolutional neural network that you can train on your own images to run a customized image classification engine. So let's take as an example, let's say you work for a car manufacturer and you have lots of models in your car family, and you want to create a machine learning model that is able to recognize your own car brand types. Let's say you are BMW. We had BMW in the keynote, and thanks to BMW for being part of our keynote. So let's say you are BMW and you want to train your own machine learning model that can recognize 3 Series, 5 Series, X, X1, and I8, or what models they have. First step is collect the data. So you collect a lot of images from all of your car models with all of the different angles and whatever variants you have. And then you label those images by writing down, okay, this is a 5 Series BMW with station wagon or something like that. And then you can apply this image classification algorithm to train an algorithm to recognize all of those pictures. And the way convolutional neural networks work, so who knows what a convolutional neural network is? I know it's a mouthful. Again, we go to Wikipedia and try to figure this one out. So a convolutional neural network tries to emulate the same pipeline that is happening in your brain. So what happens is it takes all of the pixels of the picture and it runs them through a convolution stage. A convolution stage is like a Photoshop filter. So when you run Photoshop and you run a filter that enhances the edges, that makes your image sharper, that's what a convolution does in math. In math, it's a matrix multiplication with a specific kernel that runs on top of the picture. We don't want to do too much math here, but this is essentially what's happening. So in a convolutional neural network, the first step is here that we apply a lot of masks, a lot of filters on top of the image that are differently configured. In the beginning, they are randomized, and then they are trained to be more efficient. And those filters extract features. So the feature extraction here happens through convolution filters. Then we subsample them. That means that we make the image, put them into buckets so that we only have a handful of features. Handful meaning it could be hundreds, it could be thousands of features, but it's still less than 1 million pixels we had. And then we run them through a neural network that has different layers of neurons that try to identify those features. And depending on the complexity of the image you want to recognize, you can get away with just a dozen nodes or 18 nodes, or you can go all the way up to hundreds of layers that are trying to interpret and make sense of that image. So that's essentially what a convolutional neural network does. You don't have to understand this, you don't have to program this. You can simply use the ready-to-use image classification algorithm that you can tune with some parameters and use in production. And that is what this notebook is about. So again, in the beginning, we import some stuff. We import the right container image where the image training algorithm is. Then we can fine-tune the model in terms of our requirements. So in this case, we load some images. For images, we are using a research data set that is from the University of California, which is called the Caltech 256 data set. It's a data set of about 30,000 images that are grouped into 256 categories. But in this case, this is where you would bring in your own car images or motorbike images or plant images or whatever. So you load the images, reformat the images into the right data structure for the machine learning model. You write an input specification, which basically tells us, okay, I am using 3 layers for the 3 base colors, red, green, blue. I'm using 224 by 224 resolution images. So you can expand that to bigger resolution images, or you can shrink that depending on your use case. This is where you tell it how many training samples you're going to use. This is 15,000. You may have noticed that we are starting with 30,000 images. Why are we just using 15,000 something here? Anybody has an idea? Training? Yes, so the idea here is to separate the training data set from the testing data set. It's like at school. At school, we like to cheat. We don't want our machine learning model to cheat, and we don't want it to learn something that we are not aware is giving away the right information. So what we do here is we separate out some of the data for training, train on that, and then we use the remaining data that is unknown to the model to test how well it performs. And if we did a good job with training, it will be able to recognize stuff that it has never seen before, and then we know our model is really working. So this is where you can separate the data into training and testing examples. Here is where we tell it that we have 256 plus an unknown class, or 257 classes, and some other parameters. Training is very similar. It looks like complicated code, but this is just a data structure that encapsulates all of the training parameters. And the actual training happens with this code line here, where we say, where we simply give all of the parameters into the training call, which is SageMaker create training job. So one API call, lots of parameters that describe your training job, and then SageMaker will, again, create a fleet of machines, as many as you like, of the right instance type that you pick from, run all the data through all of the machines, and then it will pop out a ready-trained model into your favorite S3 bucket. So, again, same thing for deployment. It's just different algorithms. So basically, we are running through the whole set of sequence that we did before in the linear learner, just with a different algorithm. Slightly different data structures, different algorithm, but the process is the same. We go through training, we go through deployment, we get an endpoint, and then we can present images to that endpoint, and then it'll give us an answer. So in this case, I have the endpoint already up and running, so let's download a test image here. So what kind of image do we want to test on this new model here? What is your favorite animal here? Squirrel. Okay. So let's pick a squirrel here. So let's go to a website that has free-to-use images and type squirrel. Okay, here are squirrel pictures. Let's pick this nice squirrel here. And let's copy the image URL just to be sure. Here's our squirrel. I have the URL here. And now we go find our linear, not the linear learner. We are going to, this is where I get confused. Squirrel. Here we have it. Okay, here's the image classification. This is where we put in our squirrel URL into this bit of code. As you can see here, Jupyter also supports simple shell commands, so we can use our favorite wget to download the squirrel image into the test2 JPEG file. So let's do that. So that's not the image I downloaded. Did I do something wrong in my copy paste? No, test 2. File name test 2. Okay. Somehow it did not download the image. Yeah, it should be downloaded into test 2. And then, file name, it should. Okay, something's wrong here. So it is definitely the squirrel image here. It is in test 2. File name equals test 2. Anybody found the bug yet? Sorry? It's saving to test JPEG. Yes, you're right. It is saving into the wrong one. Okay, but maybe there's an error here. Okay, let's go with the cathedral, and I'll figure it out later. Sorry for the blunder here. In this case, we're using a cathedral. The interesting bit of the code here is actually where we get to use our fully trained endpoint. In this case, we are reading the image, we are putting it into a byte array, and then we are presenting the byte array with the image to upload it into our endpoint here, and then we call the invoke endpoint method that will present it to our web service API. And if we run that, we get a label. In this case, it's Tower of Pisa. Well, it looks like a tower. It looks like an old monument building. The reason it's thinks it's the Tower of Pisa is we didn't have very different towers in our training set here because it's just a small demo training set, but it is coming pretty close. And again, it gives us a probability. So with 48%, it looks like a Tower of Pisa, but the model did detect, well, it's not really long, so maybe it's not 100% Tower of Pisa. Okay, I'll figure out the bit about the squirrel. Sorry for the squirrel bit here, but I think you get a feel about how easy it is to put this into production. Again, please check out the documentation, check out the example notebooks. All of these are just the example notebooks. It will teach you how to use the code, and then you can take it from there. You can copy-paste the code from the example notebooks, put them into your own application. You can automate everything, and you can pick from one of the many different examples from the documentation here. So with that, we have time for question and answers. And don't ask questions about why squirrel images didn't load. So any question here? Yes, the guy over there. Maybe, do we have a mic for the audience? Okay, we have a friendly little helper here. Meet Kevin. Kevin is going to helping us out with the mic here. Thank you, Kevin.
Thank you. Thank you. Okay. Got two small questions. One is, are the pre-designed model open source? Mm-hmm. And the two is the Jupyter Notebook the only coding environment for SageMaker?
Okay. Yeah. Question number one, the Amazon supplied algorithms, are they open source? The answer is no. These are our proprietary, very tuned, very optimized algorithms, but you own all of the model data. So the model that you create out of our own algorithms is owned by you. You can do whatever you like with them. And we are currently working on documenting how the model data looks like. So if you want to use an open source model, you can always encapsulate it in your own Docker container and bring it into SageMaker. And if you are creating your own deep neural networks, then you're using the standardized open source Docker container that we provide you for running TensorFlow or MXNet or other models. And then you plug in your Python code in there. The second question is Jupyter Notebook the only environment? The answer is no. You can use any environment to interact with SageMaker. SageMaker is just a service with an API. I'm using Jupyter because it's convenient. You can use RStudio. You can use a shell script. You can use whatever environment you like to interact with SageMaker. It's always the same thing. You import the SageMaker library. You call the training function with the parameters. You call the deployment function, and you're done. So the Jupyter Notebook is just an added convenience on top of the rest of the SageMaker service. The question over there, yes? Cool t-shirt.
Can you show again where you got the endpoint to make predictions?
Sorry, what was the question?
To make predictions, you got the endpoint?
Yes.
Can you show me again where you got the endpoint from?
Oh, yes. The endpoint is created here at the deployment stage. So create endpoint. Here you give it a name. In this piece of code here, you give it a name. Here are the parameters where you put in the endpoint configuration. This is where you put in how many instances, what instance type. And then you say SageMaker create endpoint with those parameters. And the output of that function call is going to be the URL or the ARN, the Amazon resource name of the endpoint that you can use. And that is an HTTP RESTful endpoint that uses AWS API gateway with our authentication mechanism. So you can use it just like any other API from AWS and interact with that endpoint. If you want the graphical overview, you can always go back to the SageMaker console, where you get a list of models, endpoint configurations, and endpoints. So another way would be to log into your environment, because my token has been used up, and then you can simply go to the AWS SageMaker console, and there you will find the endpoints listed. Of course, we also have API calls for listing all of the endpoints, so you can see how many endpoints do I have. And if you have a naming convention, you can list them by version. If you put in the version as part of your name, you get a nicely list of the versions of the endpoints, and then you can do all kinds of fun stuff like A/B testing and stuff like that. So again, let's go back to the SageMaker console, and there you can see the list of currently configured endpoints. So in this case, I have a couple of endpoints. Let's see, the one that we created right now must be this, should be this one. Yeah, one of these one. So we still have some time for questions. Let's give it 5 minutes for questions over there.
Thank you very much for the presentation. I would like to ask you if you could elaborate on how the model is pre-trained by Amazon, and like what kind of classes, is it animals, what kind of like buildings, passports, whatever, and how you can adapt them, like for your own purpose. Say you have 20 different types of passports or whatever.
Okay. So in the case of the algorithms that are part of the Amazon SageMaker service, all of the training data is supplied by you. So we don't provide any training data. This is coming all from your own application. Now, in terms of the algorithms, they have been tuned based on our experience with running those applications, these algorithms in production. And they have been tuned to support streaming training mode as opposed to batch training mode. And they are tuned to support parallelization, at least most of them. There is a full presentation on YouTube that you can check out. Just search on YouTube for AWS reInvent infinitely scalable machine learning. And this is a rundown of most of the algorithms and what we did behind the covers to tune them. And the goal of tuning the algorithm is to make all of the algorithms very efficient in terms of parallelization and in terms of getting a lot of training, a very high quality training model at the least expense of resources. Did that answer your question? Okay, thank you. So let's do a last question now, and then if you have any further questions, you can find me after stage here, because I still have 1 or 2 slides to wrap this up. Last question? Okay, people are... Okay, last question with the guy with the funny T-shirt.
What if I have pre-trained models, maybe stored in S3? Let's say multiple pre-trained models stored in S3.
Yes.
How can I deploy that maybe without using Jupyter Notebooks?
Okay, so if those models have been trained already with SageMaker, you can keep them in S3 and deploy them afterwards. So in this case, you see here, these are the models that are stored and known to SageMaker. If you created those models on your own with your own algorithm, then you can put that algorithm in a Docker container and load that model from S3 and simply use SageMaker as a purely deployment mechanism. But in this case, you need to make SageMaker understand what your model format is, and you can do that by encapsulating your algorithm code in a Docker container. Actually, you can actually cheat a little bit, because if you look at the container we use for running an MXNet model, this is just a Python execution environment. So chances are that your model is a Python NumPy kind of model or something like that. So you can simply use the MXNet execution environment and write some code that loads the model in your format and then executes the model running SciPy or NumPy or whatever your execution environment is, and you're done. You just pretend it's an MXNet model. In reality, it's just a Python script. So you can do that. If that doesn't work, you can always encapsulate your algorithm in a Docker container and then use your pre-trained model from S3. Okay, let's wrap this up with a couple of last slides. So we went through creating a notebook instance. We went through loading, visualizing, and preparing the data. If you are a little bit familiar with Jupyter notebooks, you can use matplotlib to do some more fancy plotting of your data. We went through training your model and through inference. And again, if you don't know how it works, just pick one of those example notebooks, copy, paste. This is the best way to learn this stuff. So as a next step, I would encourage you to explore the built-in algorithms. So find the documentation. Right now, we have about a dozen algorithms that span very different use cases. We have clustering algorithms, we have image classification, we have natural language processing, we have sequence-to-sequence for translation. So lots of great selection of algorithms, including dimensionality reduction and other useful bits in machine learning. So you don't have to reinvent the wheel here. You can use our finely trained models here. You can build those machine learning endpoints into your web, mobile, or IoT apps very easily. You can even deploy your model to a device using Amazon Greengrass. So check out Amazon Greengrass Machine Learning Inference, which gives you the tools you need to deploy models into your devices in an IoT context. Try to build a fully automated model cycle so you can collect new ground truth data where your users are telling you, no, this is not the Tower of Pisa, this is something else, and then take that data as new labels and new data to retrain your model with better data. You can use SageMaker to run A/B tests to test models with different data and have a whole new A/B testing environment there. You can automate everything using code pipeline or AWS step functions as orchestrators. And if you are having trouble labeling the data, so collecting data is really cheap. It's the labels that make machine learning difficult, because if it's a new thing that hasn't been done by a machine before, which is the whole point of machine learning, then you need someone, human, to look at the data and tell, this is a cat, this is a dog, this is the Tower of Pisa, this is a squirrel. And that means you need real humans to look at your data. And if you're running out of humans, you can use the Amazon Mechanical Turk service to help you label the data, because Mechanical Turk is an interface to human workers so that you can set up a website that displays the picture and have a human worker from the Mechanical Turk platform look at your picture and tell you it's a squirrel or something else. And finally, you don't have to stop with a single model. You can have a combination of multiple models that you call in sequence and create a full pipeline. So you might start with a data collection process that has thousands of attributes, and then you can use principal component analysis to boil them down to just 300 attributes, and then you use a k-means clustering bit, and so you can use machine learning models as building blocks. With that, we are looking forward to learning from you. What are you building? So try to build something cool out of SageMaker, and hopefully this session has been useful to you in learning more about how it works. Thank you very much.